So, Calista, I think my first question is for you, and I would really like to understand, Calista, from you the what and why of RISC-V. An introduction to RISC-V for all our audience, please.
Well, let's go way back in time. No, I'm just kidding. We're going to go a little back in time, but not too far. So, you know, in the 1980s, there was this massive processor competition, right? Everyone had a different processor, and they were competing to be really the heart and soul of computing. And at the end of the day, amongst all of these different experiments, Intel really kind of like barreled out in front with, you know, volume, end-to-end foundry design, everything. And they were able to get to scale because they were investing millions of dollars, hundreds and thousands of engineers. So much went into that. And you could have a processor, a computer, a server that had a constant supply of energy plugged into the wall. Okay, 20 years later, we started to see things that were more portable. Cell phones, you know, laptops, ThinkPads, you know, small devices that didn't connect to cell phone towers at all. And there was another competition. It was another wave of competition in microprocessors. And, you know, ARM really came out in front. They really had a model that was disruptive at that time. We are now at the next point in history, the next inflection point. Because along the way, along that hardware journey, we discovered something. We discovered that collaboration in software could help the entire industry form a foundation upon which they could still compete. So along came Linux. IBM planted $1 billion flag in the industry and said, we are all in. We are going for open source as the building block, the foundational building block for many of our things. And now they had their own software, but there was this sort of like culture that said, let's all share things so that we can build together and collaborate better. So that moment now is here in hardware. At the same time that there's an explosion in customized processors. So custom processors have taken off. So there's opportunity, there's flexibility, and folks want to accelerate that development roadmap. They don't want to wait for scale. They don't want to own their own foundries. They want to participate as a stakeholder in a community and not be the entire community themselves. So the two reasons really that RISC-V is now catapulting forward as the most prolific open ISA that this microprocessor industry has ever seen, like more design houses on RISC-V than any other architecture in history, is two reasons. Number one, the disruptive technology. The approach of the technology is actually modular. You have a very small base set of instructions, 47 base instructions in the ISA, and then you can pick and choose from a menu what you add on to that to build your implementation. That's a lot different than the incremental approach of other ISAs that start with 1,500 base instructions. I don't know anyone that can wrap their head around 1,500 instructions. I don't think there is anyone that knows all of that in depth. So those legacy ISAs have built on for years and decades. RISC-V has taken a modular approach. So that technical advantage, along with it being fully open, and you have design flexibility to take that in any direction you choose. You are not constrained, and now we get into the business reasons. You're not constrained by license. You're not constrained by agreements with vendors. You're not constrained at all. It can take 2 to 3 years just to negotiate a license. You don't have to worry about that. Anyone can take RISC-V and go in any direction they want. So with that design flexibility means you have unconstrained opportunity. You really can build in any direction you wish. If you want to build servers, if you want to build earbuds, if you want to build an HPC system, if you want to build cloud, if you want to build an automotive, you can take that same base ISA and combine it with other instructions to build your implementation. That means that you have unlimited development partners, folks that help you, put together a product to go to market, collaborate on the development and what goes into that design. You have unconstrained supply chain, where you can go to get the design elements, the IP, the testing, the verification, all kinds of parts of that stakeholder community. You can go wherever you like. That opens up where you can take your product. So unconstrained markets. If you want to go into different geographies, different industries, you are welcome to expand that opportunity. Remember, this is all coming at a point in history where the opportunity is absolutely exploding. We are now seeing predictions for 50 billion connected and IoT devices by 2030. That's just around the corner. Every time one of these predictions come out, by the way, they say, oh, I'm sorry, I was wrong. The market is actually growing faster than I thought. So every single chart that I've seen from the analysts just shows this explosion, this skyrocketing opportunity. That means that investors are keen to get engaged, development teams are keen to get engaged, and everyone is saying, you know what? This is kind of the Linux of hardware. Intel's even seen that. Just this year, a month or two ago, they planted the billion-dollar flag and said, you know what? We're all in on RISC-V. Let's help build that ecosystem. So that's why it's so important. And I did warn you, I could talk for hours about how exciting this space is, but let me hand it back to you.
Great, great. Thank you, Calista. I mean, I don't really belong to the background, but all of this was so comprehensive, and I'm sure the numbers were really mind-boggling. So thank you so much for all the details again. And I think I'll pass on the next question to Shiva. So what is RISC-V for us as Maven Silicon? You know, what were our reasons of collaboration with RISC-V?
Yeah, Calista nicely explained why RISC-V is becoming popular and what is going to happen in the future. To summarize, yes, it's free. So we don't really need to live with license restrictions, royalty free. Of course, in the world, nothing comes for free. When it comes to realizing the device, whether it's going to be IP or subsystem or SoC, we need to invest money, time, and that's how things are going to happen. But the most important thing is freedom. It's open ISA, so engineers like me, we love to play with it. We want to customize the ISA as we prefer, and that's also highly needed for the current scenario. You just look at this. Monolithic semiconductor scaling is failing. So it's almost reaching a saturation point. So the big question is, how can we improve the performance of any chip? The possible solution could be like, we can think of packing more and more components. The components could be processors, but how much we can pack the general purpose CPUs? That's where we are looking at using open ISA, because we can think of creating specialized processors. Rather than choosing general purpose CPU, we can also look at the option of using specialized processors or customized processors for artificial intelligence. The best example is Esperanto. I have gone through some of the updates. I have been watching Calista's talk, and she mentioned about all these great customers. Esperanto is one of the big customers. They have designed SoC called ET SoC. They also call it like different flavors, Maxion, Minion, something like that. I need to still understand more, but they pack more than 1,000 RISC-V cores, and that demands more than 20 billion transistors. You just think about the complexity, right? And that's meant for AI application. And that's what really needed at present. So we really need open ISA. But why RISC-V is something important for Maven Silicon? As a founder, why I chose to work with RISC-V International, or why I introduced a RISC-V processor design as part of our curriculum. You know, a lot of engineers come to Maven Silicon because they want to grow as chip designer. So my responsibility is teaching them the concepts, all kinds of concepts, VLSI concepts. And then I love to see everyone as great chip designers. But before choosing any engineer, I would like to ask them questions because I want to really know whether VLSI is their cup of coffee. The important question is, you know, in India, the scenario is different. Engineers come to Maven Silicon because they want job at some point of time. But it's not going to be good for them. It's not going to be good for Maven Silicon. Let's not go behind job, how to get job. Rather, let's look at why VLSI is something important for them and how I chose VLSI. This is the kind of question I always ask any engineer because I want to find out whether VLSI is their cup of coffee. So I asked them one simple question. What is the difference between laptop and smartphone? Sometimes they think so much, but what I really want to hear from them, if they say, generally we use CISC processor, complex instruction set computer for laptop, and we use RISC for smartphone. If they have got that kind of understanding, that might excite me. Wow, he's my boy. I love to work with him because he has got the understanding, the difference between CISC and RISC. Of course, nowadays we use even RISC also, especially RISC-V for everything. Look at Esperanto's chip. It's kind of supercomputer, right? So we don't really need CISC. CISC might go off. So I want every engineer to explore processor, and RISC-V is the best case study. If someone wants to understand logic design, how basically we create the IP or subsystem, how they can approach creating the architecture. Of course, they need to understand digital electronics, right? So RISC-V is a case study. That's how we introduced RISC-V as part of our curriculum. Also, they need to understand big things. If you look at our course, it starts off with the foundation course. As part of our foundation course, we take them through SoC development process. We show them what is there inside smartphone, chips like A14, and how we build such SoCs. But to understand anything like SoC or subsystem, they need to understand what is processor. That is the right way of approaching VLSI, very large scale integration, and how we use VLSI to create complex chips or SoCs. Why this is something important, I just want to take a few more minutes. If I look at VLSI training, it has always been about teaching languages and methodologies, kind of bits and pieces. That is how it has always been. Even in my career, right, I worked on different point tools like simulators, different kinds of verification tools, different kinds of languages. But I didn't have complete idea like how any system would look like. I didn't have any idea about processor. That's what I really wanted to redefine. So in India, what happens is engineers learn these languages, could be Verilog or VHDL or system Verilog, and then they want to add all the keywords in their CV or resume. Then they look at like how fast I'm going to get my job. That is wrong. You understand like how we create systems. So what is laptop? What is there inside? Maybe do you understand anything about BIOS? And when it comes to smartphone, how we create smartphone, why we prefer SoCs, that kind of understanding is really required. That's why we included RISC-V processor as part of our curriculum. So today I'm so happy. All the engineers, they go through processor. So whoever comes to Maven Silicon, they have to learn RISC-V processor. That's how the course starts. And that's the good news I would like to share with Calista. All right.
I love that. I love that everyone learns RISC processor.
Thank you so much, Shiva. I'm sure that whatever you said answers to a lot of questions that I'm sure the folks might have around that. Why Maven Silicon and RISC-V. So thank you so much for this beautiful explanation.